We've moved from the physical into the logical. And our first topic is VLANs and spanning tree. Spanning tree is almost like the bonus side note that I've added there, because as I was putting these slides together, I started thinking to myself, if someone were to ask me, just a random passerby in the street were to come up and say, Jeremy, what's the most important topic of all networking? I'd be like, well, but the first thing that came to my mind is VLANs immediately, and then I started arguing with myself. I'm like, well, NAT, you got to have NAT to access. But if I were to step back, I mean, taking networks as a whole, networks all around the world, now I would just say, okay, what's the most important topic? It would be VLANs. And I know some of you are like, well, IP addressing. Well, yeah, but VLANs go right along with IP addressing. It's like one and the same. A subnet is a VLAN and all that. So what I want to do as we get into this, we're still keeping our design in mind, our goal in mind, our focus of this entire series. We're designing the network for this company. And we now need to implement their VLANs and talk about how we're going to set up the VLANs for the network. And still at this point, I'm still in the logical discussion phase, like let's design it first. So I'm going to go through VLANs, kind of do a quick review of what they are, then revisit our design and see how they apply, where the trunks are going to be, how we tag the ports and things like that. And I also want to bring in virtualization. I'm going to show you something. Hang on. I showed you a couple nuggets ago, maybe in the last nugget, about some of the feedback I've been getting. And Dan Charbonneau, the guy who runs CBT Nuggets, amazing guy, just made a quick continuing feedback series that he just rolled out to where people are saying, well, what, without filling out the whole survey, what else would you like to see covered? And I want to show you some of the replies that I've been getting. Some other topics, and some people just throw out bizarre stuff like VMware View, and I want to tie in. You can see VMware is virtualization. I'm starting to add that in there, but there's some topics where it's just too far outside the scope of CCNA. VMware View is kind of like thin client provisioning and things like that VMware has, but kind of Citrix competition. But some things I just can't talk about. How does firewall tie? A lot of people asking for ASA stuff, wanting to see ASA, and I thought, well, sure, why not? Let's add a little of that as we go through. Real world implementation, T1s. Here's one: where to place web and email servers in the DMZ Windows domain, how to protect them from attacks. Lots of discussion. Nobody agrees. That deals right with VLANs. We're actually going to segment those, and I'll talk about some of that as we go through. So this is, again, I'm just going through. Some people are just awesome. How to get a girlfriend who isn't ugly based on my Cisco certification. So I'll be covering that. But more on the ASA, keeping it real with little theory. That's what we're all about in this series. So again, just as I'm going through, there's just a ton of. I know some of you are submitting this stuff, and this has to be the most hilarious thing, and I don't know if this was purpose. My last name Chara is Romanian. It means crow, and they go caw. So I don't know if that was on purpose, but I thought it was very witty. But anyway, I just want the reason I show these is I want you guys to know that this series is being generated from the topics that a lot of you are talking about, along with, of course, I'm guiding it myself to where I'm saying, okay, well, based on the design, we have to talk about VLANs. I'm adding things like virtualization. That came straight from the feedback that I've been getting, because there's a lot of that, and how do you integrate that and all that. So then we'll get into spanning tree, rapid spanning tree, and then configuring the MDF as the root bridge. In this nugget, I'm assuming, based on my track record thus far, we'll probably get through VLANs. Next nugget will be spanning tree. So before we get into VLANs and applying them to our design, let's talk about what they do for us. Again, talking about the why. Some of the feedback I got, someone said, make sure you're filling in the why behind everything, because that's what really makes master technicians, and I fully agree with that. Why do we have these things? So we've got our usual switch. It's a little, 6-port switch that we got from whatever, and we start connecting devices to it. And once it's full, we connect, a crossover cable, connect another switch up here, and put devices on that switch until it's full, and connect another crossover cable. Just keep filling up our network as we go. In that environment, we have one collision domain per port. Now, I say that just to, again, remind us that a switch is better than a hub. A hub has one collision domain per device. So what that means is when this guy is speaking, it's not bothering anybody else on the switch. He's just sending and receiving his traffic. He's isolated from this and this and this and all their conversations. If I were to open up a packet sniffer on this guy, the only thing that I would see is my own traffic and, I'll move down to my second point, all of the broadcasts, because all the broadcasts are sent to all ports. Now, that's a big point to bring up because that's one of the differentiators with VLANs. When this guy sends a broadcast, like he boots up, he has no IP address, right? So he sends out a DHCP request. Well, in IPv4, that's a broadcast packet. So everybody, including the DHCP server, ends up getting that request sent from Fred the computer here, and it says, hey, I'm Fred, I need an IP address. The DHCP server out here gets it and replies back. Now that one goes direct. It's not a broadcast. And since we're one collision domain per port, it doesn't bother anybody else. So it goes direct back to Fred and he gets an IP address. But think about it. Start multiplying that out. And you've got DHCP requests coming out all the time. People are always rebooting their computer, needing new IP addresses, that kind of thing. That's just one type of broadcast. So all broadcasts sent to all ports. One LAN is equal to one subnet. So, for instance, we might have, let's just use 172.16.1.0/24. Again, not using our design as of yet. We might have that subnet, which then applies to everybody. So all the devices on every single switch needs to get an address from that subnet, and that leaves us with very limited access control. Meaning, if I want to prevent this guy, who I know has been causing trouble, from accessing this guy, it's not very easy. I mean, you can use things like VACLs, which you'll get into if you get into the CCNP, which requires a pretty huge understanding of VLANs in the first place, but it's not something that's normal to do. Now, let me get real world on you here. We're not usually caring about, we don't usually have a guy we're like, yeah, that guy Bob in the corner, he hacks our network all the time. And, you know, we're not identifying the evil user and saying, well, let's stop him from accessing this. We're identifying all our users as evil. in a way. I mean, you can't trust your users. They're downloading script kiddie utilities, unleashing attacks all the time on areas of your network. So we can't leave it to just say, okay, you're a trusted entity. So you might want to say, okay, well, I want to isolate my user communities from my servers and all of the things that are out there, and at least put them through some kind of filter. Well, without VLANs, it's just not possible. Now enter VLANs into the picture. A VLAN breaks your LAN into multiple LANs. Virtual LANs, you might say. Here's what I mean by that. If I had a switch and it was 4 ports, and I said, okay, those two are VLAN 1, these two are VLAN 2, it would be as if I took that switch over my knee, did some ninja move, and went, chop, and snapped the switch in half, and had 2 working 2-port switches that I could now attach computers to. But they're still, you know, without the ninja move, there's still one switch. So these guys are completely isolated from these guys. That's awesome. Here's why. First off, it allows you to logically group your users. It just starts making sense, meaning I can say, okay, I've got the users that are all in VLAN, I'll just say 1. VLAN 1 is the users. And they've got their own, and this is what I'll just link these two together, they've got their own subnet. Yeah, the user group, they're 172.16.1. Everything with that is all VLAN 1. The Wi-Fi is going to be VLAN 2. We'll say the private Wi-Fi. And that's going to be 172.16.2. You know, and so just in your mind, it's pretty awesome because you start thinking, okay, well, logically, I've got this whole group of users. If I hear an IP address, like you're troubleshooting, you're on the phone with somebody, you're like, hey, what's your IP address? And you walk them through command prompt, ipconfig, all that. And they say, oh, it's 172.16.2.50. You go, oh, okay, immediately, shink, in your mind, you're going, you're a laptop, because you're on the Wi-Fi network. You have the permissions are going through your mind of what's set on the Wi-Fi. It works great. Or your servers. Your servers might be 172.16.3. So you can create all these separate groups of users and servers and printers and Wi-Fi and all these different groups. And we'll go back to our design in just a minute and talk about how we did that for our company and our organization. But it just makes sense in people's heads, well, at least I'll say for the network people, of how that works. Now, in this little picture that I've got sketched up here, we've got the blue and the red VLAN, which maybe blue is VLAN 1, red is VLAN 2. So all of these ports, like these 3 ports, are all part of the blue VLAN on that top switch. If somebody sends a broadcast on that blue VLAN, only the blue ports up here get it. Now, when it goes out the trunk port, like here's the broadcast packet. Little funky shaped packet there. It decides to make its way down this trunk because a trunk, by default, sends all VLANs. So all the VLANs go across. As soon as the switch realizes, whoa, I've got this broadcast, it's going to go out the trunk, it puts a little tag on it, colors it blue. So that way, all the other switches that receive it, the next switch in line gets it, and it goes, oh, okay, this belongs to the blue VLAN. Or, in reality, VLANs don't have colors, they have numbers. That might be VLAN 1. It'll go, oh, okay, that's VLAN 1. Well, let's send that out here and here and here and here. And, oh, I've got, well, okay, this doesn't work, right? That's one port connecting to 2 switches. It's a weird port. So you would have another port right here that would actually be plugging into. That would be another trunk. And as it forwarded the broadcast on down to that one, it would put that blue tag, or I used to call it a shim. I think of little shims like you get at Home Depot for refrigerators. You kind of squeeze it in there, stick it on there so that this switch gets in. It goes, okay, you're blue. You go out these ports. So it segments the broadcast domains because broadcasts are good and yet evil at the same time. The network needs broadcasts to work. It doesn't work, at least with IPv4. It doesn't work without them. However, the more computers you have, the more broadcasts you have, and the slower and slower and slower all your devices and the network gets because broadcasts slow things down. So this isolates the broadcast to only go out certain VLANs. If someone on the red VLAN decides to send the broadcast, comes in here and comes out all of the red ports all the way around, because as it goes down the trunk, the broadcast gets tagged with the red packet, and that's what lets. You know what I mean. All the switches get that, right? So 2 things that I really want to point out and bring to the forefront, the whys. I would say these are kind of cool. Like, wow, that's neat. I can scale my network. I can identify my users. That's neat. I like it. This is a lot of the why. Why do we have VLANs? Number 1, access control. And don't let me leave this out of the why too. Of course, we want to scale our networks big. Without VLANs, we have to start shoving routers everywhere to segment the broadcast domains. So yeah, that's a big why. But I would say this is a huge part of why we do VLANs. Once I've got all my users in their own little community of VLAN 1, and they start trying to cross their VLAN boundaries, then they're going to be able to pass through a filter. Why? Well, in order to get from the blue VLAN to the red VLAN, you have to go through a router of some sort to do it. And once you hit a router, now you have access lists at your disposal. I can say, okay, these guys, are not going to be allowed to cross into the red VLAN, or if the red VLAN were a group of servers, or the voice over IP. Oh, voice over IP, we'll talk about that when we get back to our design, right? So access control is great because anytime you put a VLAN boundary, I have the ability to segment what traffic is able to cross between those VLANs. I'll also throw out another big one, which is quality of service. When I get to a congestion point, like let's say this comes out to a router and that connects to another office and all that kind of stuff, and I have all these traffic, this is a gigabit per second, so 1,000 megabit per second link coming in that goes to a T1 line, which is 1.5 megabits per second, right? So you're at 1,000%, even more reduction, right? Huge reduction in speed. Well, all these packets are going to bottle up at this point, and I can start saying, okay, well, you know what? The stuff from VLAN 2, which maybe is my phone VLAN, needs to go first out on that T1 line. I can segment. I can say, okay, that VLAN has the priority over the other VLAN. That's another big reason why we have these VLAN boundaries. Here's the fun part. We get to be immediately practical on the VLANs by applying them to our design. Remember, I actually just snapshot our Visio spreadsheet that we created in the first nugget of design for our site. Now, this is our new branch office. We've got the MDF, this is our core, and we've got the core switch 1, right there. We've got switch 2 also located in the MDF, just providing some port density, a lot more ports for our users and phones and servers and everything to plug into. Then we've got our switch 3 sitting down here. That's on the second floor, the IDF. Just providing a bunch of ports for the users on the second floor, essentially just the user community to plug into. Now I'm going to drag, and I just put a couple notes. I put switch 1 is acting at the core. That's going to provide the routing. That'll be our layer 3 switch. I'll talk about that later. I just realized, wait a sec, I didn't put that on my objectives. Let's do it. I want to talk about that next, because that's going to be very, very, very significant right away. Then we've got our switch 2 and 3 that are just hosting our users, our phones, our wireless access points plugging into the ceilings, that kind of thing. I'm going to bring over the spreadsheet that was created to specify the VLANs. Now, again, just to review this, we've got our subnet and VLAN spreadsheet. They go hand in hand since a VLAN equals a subnet. Corporate office is this group of IP addresses. We're not even worried about that. So the first VLAN that I have right here is VLAN 64. That's going to be the voice over IP VLAN. I like drawing them as bubbles. It just makes sense in my head. So VLAN 64 is voice over IP. So just put VoIP as the VLAN right there. That'll be the to 10.1.64.0 with a /23 subnet, which actually makes the range 64 through 65.255 is the last. So both of those, that's why there's the dark box around them in Excel, is because those guys are one subnet. I've got VLAN 66. Now I jumped over 65, doesn't make a difference, isn't going to hurt anything, simply because I wanted the VLAN number to match the subnet number right there. So VLAN 66 is client. Or I guess you could say the client data. That'll put. That's our PCs go in there. Now I'm going to stop right there before I go any further to talk about a few key things. Number one, why create two VLANs? Why do I have a voice and a data VLAN? Can't I just have one? Well, a couple thoughts on that. Number one thought that I have is no, because this is a huge security risk. You don't want your PCs in the same VLANs as your IP phones. There's already a ton of attacks that a client can pull off on an IP phone. I mean, for instance, just out of the box, a client PC, if he's on the same VLAN as an IP phone, he can pull open his web browser, type in the IP address of that phone, and wham, he's in the web interface of the phone, which is turned on by default. A lot of people leave it on because it's great for administrators to help troubleshoot the phones and access them that way. A lot of people can turn it off if they want to. But by getting to the web interface, people can see if the phone's on an active call. They can get the packet statistics the phone is sending, when calls are happening. They can get the reconnaissance data of the network, and what I mean by that is they see the IP address of the call manager server. They see a lot of the core codecs, what's being used to run the voice network. I mean, if you're a hacker, an intruder in the network, that's a lot of valuable data that you just gathered right there. Not to mention that if they're on the same VLAN, it's one less barrier that they have to start sniffing data from phones, and if they can do that, they can reassemble it. And they can get phone calls. It's like recording phone conversations that people are having. And a huge privacy intrusion there. So that's the number one thing. And that's the number one reason we segment it into another VLAN, is because no, we don't want those together because of the security ramifications. Second reason, this branch office, hang on, what was the size? 20 miles, okay, blah, blah, blah. Okay, 200 employees over 5 years. Okay, 200 employees. That means, and I'm just looking on the lab requirements right there. So 200 employees, that would mean 200 PCs and 200 IP phones minimum, meaning just one per user. There's not general phones. There's not, that kind of thing, lobby phones. Minimum. So that's 400 devices That's a lot of devices to have on one subnet. I mean, security aside, that's just a lot of devices to have there. So by having separate VLANs, I'm now making my network more efficient as time goes on, because these things are going to grow to a max of 200 devices each, and I gave myself enough IP addresses to where they could grow to 500 devices each, and that would work okay. 500 being a pretty, I would say that's a pretty high limit on number of devices per subnet, but gives you the room for growth should you need it. We then, going back to the spreadsheet, have VLAN 68. That's going to be our server VLAN. So 68 is our server. Why did I create that VLAN? Number one, to where I've got my own pool of addresses. I'm not competing for IP addresses from the clients. I'm not overlapping the DHCP scope in any way to manage my servers. Second reason is because of the security. You know, if I have a server, I want to implement some kind of filtering. I don't want these guys to have full access to those servers. You know, I want to block a lot of the, you know, compromisable ports and things like that at certain points. We can do that. I go down my list. I've got the public Wi-Fi. Okay, that's a big one. VLAN 69. I'll put pub Wi-Fi. My pen's getting pretty smushed there in my circle, but my public Wi-Fi, huge on the security. This is, remember what our public Wi-Fi is for. We want people to be able to come, bring a laptop, bring a smartphone, bring a device, a tablet, PC, whatever, into the lobby of our organization. So they've got their little, you know, widget here, and they join the network just to get internet access. So we have to say, who are these people? Well, strangers, vendors, random people that happen to run in off the street. Somebody that just needed to access the internet to get some movie tickets while he's on the way before they sell out. You know, all those kind of things. I'm coming up with random things just to say we don't know who these people are. They could be people sitting in the parking lot jumping on our Wi-Fi because our Wi-Fi signal happens to go that far. So we don't know these people. We don't trust these people. Even more so, we don't trust them compared to our employees. So we want them to be in a completely isolated VLANs that only allows them to pretty much connect to a Wi-Fi access point in our organization and then go that away. They cannot access any resources here. They can't even use internal DNS. DNS should be restricted. We should deliver via DHCP some, oh, we're out here, some public DNS server like 4.2.2.2, great one, or Google's runner-up 8.8.8.8, another great one that you can give to those devices so that they can surf the internet without needing to look up names from your internal DNS servers. So huge right there. You know, again, going down, I won't draw a circle for each one, but the private lab workspace. You remember from our design requirements, the company said that we could have our own little private lab in the MDF as long as it's separated. So that's its own VLAN. Management VLAN. Again, security. Do you get the feel? Can I stop there? Do you get the feel going through this spreadsheet where it's like, okay, why this? Security. Why this? Security. Why this? Security, 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 security. VLANs are huge when it comes to security because they are going to be the boundaries that prevent these people from getting into certain areas of the network. You are the admin. You are the one that puts the restrictions between these VLANs and allows those to, you know, to be allowed to be, or I should say, to be restricted between each other. All right, so let's regroup. We have revisited the design. We've looked at the VLANs, what they are, why we have them. Now we need to provision the trunks. And, well, I'll say talk about provisioning the trunks because we'll lay out our plan for our configuration, which at that point should be very easy. Our trunks in this scenario are going to be the links going between the different devices. So let me eliminate my chicken scratch there on the screen. We've got, let's see, we've got trunks that are going to be going between our switches to deliver the VLAN. So let's go back to our project plan. Remember our task list? I know some of you are like, wait a sec, can't we just jump on the switch and start configuring? Yes, you can, but that's not the right way to do it because you can get lost with that. So what I'm going to do is I'm going to make a task list so when we do get to the configuration, we know what to do. So I'm going to type this out. Got my priority 2 list here. The VLAN configuration. I saw another trainer do this at CBT. I guess I'm going to try it. Let's where I can pause as I type, so you don't have to watch me type. But it feels weird to me to do that. So we've got our VLAN configuration here. I'm adding it today, November 28th. And what I'm going to start doing is here's the task I need. First task is going to be to add the VLANs 64, 66, 68, 68, well, all of them. Right, I won't read it, all of them, to switch 1. Now I'm adding all those VLANs right here, every single VLAN that I have in that list, to switch 1 because it's the core switch. It's going to be our layer 3 switch. It's going to be the one that routes between them all. It's going to need them all. It's going to need them all in its configuration in order to function correctly. Now notice when I drop down to the secondary, the switch 2, I shouldn't call it a secondary, the second switch, which is in the MDF, and the one in the IDF, I move down. I just add VLAN 64, 66, 69, and 71. Sorry, I just had a brain lapse there. And 71 to the list. That is because that's all they're going to need. I'm going to have the client voice over IP, the client data, the public Wi-Fi, and the management VLAN. Those are going to be the only VLANs that I need on those switch, and best practice says only add the VLANs that you want. Now, gone are the days, I shouldn't say gone, but going are the days of a little protocol that Cisco created called VTP, the VLAN trunking protocol. It was awesome, and it still is awesome. I still like it. But what it did is allow you to create the VLANs once on a switch, and they would automatically replicate. They would automatically create themselves, well, or replicate and create themselves to all the other switches. So you essentially add your VLANs here, and poof, they show up on all the other switches. Cisco now recommends you do not use VTP. Number one, because all your switches shouldn't have all the VLANs because it eats up more resources. There's no need to send data for the server VLAN to the IDF because I don't have any servers in the IDF. Now, if I did, that's a different story. Add the VLAN in there. But since I don't want broadcasts and all the traffic from the server VLAN to cross this trunk and go to the IDF, not only security-wise, but just performance-wise, because this switch doesn't have anything to do with it. It just drops the packets, so all the packets have to travel across that trunk link just to find out they're dropped in the other end. So VTP creates all VLANs everywhere. Nowadays, we don't need to do that. So I'm just restricting it to add just the VLANs I need to those switches. Now, this is adding them. Now I need to do the trunks. First thing that I'm adding on there is to configure ether channels between the switches. Going back to our diagrams, we've got these guys, which is a pair of links. We've got 2 links right here, here and here. By configuring ether channels between them, we're kind of getting away from VLANs a little bit, but we need to mention it now because of the trunking factor. When we configure ether channels, this bundles both of those links together for redundancy and performance. Now, when you bundle those, if those are 2 1 gigabit per second links, first off, I want to eliminate a misnomer. That does not mean I'm going to be able to have a client right here that copies a file to a server up here, and he gets 2 gigabits per second of performance as he transmits between those 2 points. The most any one client will ever get is 1 gigabit per second. All ether channel does, here's our ether channel. All ether channel does is say, okay, the first client goes that way, second client goes this way, third client goes that way, fourth client, it kind of load balances across the link. It's not perfect exact load balancing by any means, but at least you're utilizing both of those or 4 of those or 8 of those kind of links together to where they're not just sitting there idle, being blocked by spanning tree, which is going to be one of the next things that we talk about. So when we configure the ether channels between those guys, that's going to create what's called a port channel interface. For instance, I'm going to go underneath here. I'm going to go gigabit 0/1 and gigabit 0/2. You guys are configured in channel group, we'll just say 1. Channel group 1. It will create then this virtual interface on that switch called port channel 1. That's where we do our configuration for the trunking. We say, okay, this is where we're going to have our switch port mode trunk command. We're going to go in and say what VLANs are allowed across that port channel and say, okay, these VLANs are allowed across and all that. So I will go in, and after I configure the Ether channel, I'm going to configure those Ether channels or those new port channel interfaces that come up as trunk ports. I'm going to say, okay, you are now trunks, which as soon as I type that command, shoop, all VLANs start going across that link, all of them. And I have to start pruning them back, meaning I have to configure them and add the appropriate VLANs, meaning, well, in our case, we have to remove some of the VLANs. I don't want VLAN 68, which is our server VLAN, to go to these guys. I don't want VLAN 7 or VLAN 10, I think, which was the DMZ. I don't want VLAN 70, which is our private lab and workspace, to go to those switches because they don't need those VLANs. Now, down the road, may that cause more work? Maybe. Let's say down the road, I decide to add a server over here in the IDF. So I need to send the server VLAN 68, was it? Down that trunk. That means I'll have to create the VLAN here. I'll have to add it manually to each one of those. That's configuring each one of the switches, but that's a day in the life of a network admin. That's what they do day to day. VTP, those days were great because VTP allowed them to add and remove them from the trunk automatically. But VTP, I should mention that VTP, one of the reasons Cisco recommends not using it is because you don't need all the VLANs on every switch. But the other reason is because it can destroy your network. That's it. If someone comes and deletes the VLAN database from switch 1, that can replicate to your entire network and take the whole network out very quickly. It's very efficient at what it does. So we don't want to use that. So nowadays that's one of our manual tasks that we have to do. Now, one of the last things we'll have to do, one of them, is to assign the ports to the VLANs per the port spreadsheet. Remember this guy right here, I went into the ports and said, okay, this port gig 0/3 is part of VLAN 10, 0/7, that's going to be VLAN 68. So now I actually, when I'm getting into this, I need to go and say, okay, you guys are going to be assigned to those appropriate VLANs per that spreadsheet and lay it out. Lastly, I'm going to go in and create routed interfaces on NLB1 switch 1, that's our core switch, for each VLAN. Since it's going to be the router for those VLANs, and I'm going to talk about that in just a second, I'm going to go in and create all of those routed interfaces. Now, a couple things, and then we'll go back to this slide. First off, at this point, and I may have forgotten something, but we can always add that in just a moment, but this is the core of my VLAN configuration. The reason I did this, coming back to the task list, is because now when I do actually configure the VLANs, I've got a step-by-step guide. Now, it doesn't, I know some people would go so far that they'll say, okay, now make a spreadsheet where you go in and you type in, to do this, type in switch port, VLAN 64, VLAN 60, here's the commands that you type on the switch. I wouldn't do that for myself. If I were creating this guide for someone else that maybe doesn't have much Cisco experience at all, I would say, okay, go see 2.01 on tab number 2 right here. I'd create another little, I guess Excel doesn't let you do that. But I would, if you have 2 open, if I would double click this, add a little tab, name it, detailed steps, and I would say, okay, 2.01, here's what you type. 2.02, here's what you type. 2.03, here's what you type. Each one of these being the little section heading, if I were going to do that. But for me, I trust myself enough that I go, okay, I know how to do that. I go into the switch global config mode, and here's the commands that I know to type. And same thing for here. So for me, it would feel like I'm wasting my time to create a list of commands. Some may argue against that, but for me, I think that a list of steps is just so helpful. When I get to the site, you immediately, it's even still when I get there, I'm like, oh, you just feel that overwhelm of like, man, there's so much I have to do. And you get distracted, you spend days on things that you shouldn't. So this gives me, okay, I'm scheduling a 2-hour block, this is what's going to happen. So back getting our bearings again, we've got, you're like, wait a sec, there's a new objective. We've got provisioning the trunks, which we just talked about right there. And I just squeezed in right before we hit virtualization, which will be my last topic. It's piece of cake, right? I'm just squeezing in layer 3 switching. Now I know some people might go, wow, First off, is that CCNA material? Kind of. The CCNA might mention layer 3 switch, like you have the idea of that it's out there and what it is, but I guarantee you within a few months, years, you're going to see layer 3 switching coming into the CCNA. It's too common not to. And I would be doing you a disservice if I didn't show it to you in this series. So rather than using the router on a stick, let me show you how most people are going. Looking back at our design, we've got switch 1, which is the core. Now, I purposely purchased and spent a lot more company money on this switch than these other two switches because this is a 3750. It is layer 3 capable. What that means is I can go into global configuration mode and not only type in, let me get my right pen tool. There we go. I can type in, for instance, VLAN, what was it, 68, right? 68, and that will let me create a VLAN. VLAN 66. I can type these individual commands, and that's awesome. That creates what I would call the layer 2 VLAN. What I mean by that is we're looking at our OSI model. That's all layer 2. It doesn't have anything to do with IP addressing. I'm creating the circles that I drew up here. I'm saying, okay, I've got VLAN 66, got VLAN 68. I've got all these different VLANs that I'm creating. Those numbers may be way off. Hang on, let me just make sure, looking back at my my spreadsheet, VLAN subnet 60, oh, 60, okay, 60, that was all right. 64, 66, 68, that kind of thing. As we're going through, those are all layer 2 VLANs, and I can add devices to them, and they are now segmented at the layer 2, meaning they can't reach each other. Devices, you know, I've got some computers in here, I've got some phones here. If I put the phones in 64 and the computers in VLAN 66, they cannot reach each other because the layer 2 VLAN has done its job. But I can come up here to the layer 3 switch, the one I paid a lot more money for, and I can type in interface, notice the difference, interface VLAN 64. Interface VLAN 66. These are separate commands, not all on one line. Interface VLAN 68. And what I'm doing then is creating the layer 3 VLAN interface. Now, what is that? Can I see it on the switch? Can I look and go, oh, look, there it is? No. This is a virtual interface that as soon as I create it, anybody in that VLAN is able to reach it. Here's what I mean. Looking back at my spreadsheet, I said VLAN 64, the client voice over IP VLAN, was 10.64 or 10.1.64.0 with this subnet mask. I would type in on my switch interface VLAN 64 and then give it IP address 10, my phone's ringing. Hang on. 10 dot, see, the phone calls always blank my brain out. 10.1.64.1 as its IP address. 255.255.254.0 as its subnet mask. And now I have a valid IP address on here that everybody in VLAN 64 can reach. So I've got my little phones down here, right? They're doing their thing. They are assigned an IP address from VLAN 64 and assign a default gateway of 10.1.64.1, which is, they follow up the trunk, they reach my layer 3 switch, and the router inside of this switch, you can kind of call it a swouter, right? Because it's a router in a switch, gets that address and says, okay, I can be your router. Where are you trying to go? The phone goes, oh, well, I'm trying to reach the call manager server on VLAN 68. There's a CCM server over there. And the switch goes, oh, okay, well, let me route you through. I'll route you out interface VLAN 68, which has the IP address 10.1.68.1. It's not too much further to visualize. I mean, think of it like this. Here's a switch, and all the devices are VLAN 64, right? We've got our router. We'll say this is fast Ethernet 0/0. We give it the IP address 10.1.64.1. And over here, we've got VLAN 68, right? And there's our server. And over here, we've got fast Ethernet 0/1. Give it the IP address 10.1.68.1. And we say, okay, well, phone to get, well, this is a phone. To get to that server up there, you need to go to your default gateway, which is this router, and the router gets in and goes, okay, great, I'll route him over here, out this interface, and go to that server. Oh, okay, the server wants to get back. He'll come in this interface and come down here. Great. I'm talking really fast. So when this phone It's the same concept. It says I need to get to that server. Instead of being a router in the middle, there's the swouter, the layer 3 switch. It comes up. It's like, okay, I'm hitting you. You're my default gateway. The switch goes, okay, well then I will route you. It's a router. I will route you to VLAN 68, my layer 3 VLAN interface, and send you out this port over here to VLAN 68. It's acting just like a router does. Does it make sense? So that's all a layer 3 switch is the ability to come in here and route all these different interfaces. Let me show you something. I've got a little Cisco UC500 here in my home office that I use for everything. I love this little box. And if I can't do a show IP interface brief because it's got public IPs, you guys will be like, let's hack Jeremy today. And I'll say, no, let's not do that. So I'm going to go in, and this thing has a switch inside of it. It does. Just believe me. I was like, let me show you the switch. Well, show interface description. How about I do that? There we go. So we've got, I don't describe much at my house too well, but you can see I've got all, this is the switch inside of my device. And look at, oh great, look, this is a great way of doing it. So I've got all of these, it's a little 9-port switch inside of here. You can see I've got VLAN 1, VLAN 2, these are actual interfaces. So for instance, if maybe these 4 were assigned to VLAN 64, I would go in and I would say, okay, interface VLAN 64. Notice it treats it just like this magical interface that appeared. I'll give it the IP address 10.1.64.1. Enter. No shut. Let's power that bad boy up. And Control Z. I'll go back and do a show interface description. And now look at this. We've got this VLAN 64 interface that any port that's assigned to VLAN 64 would be able to reach. And that's now created. So this little UC5, I had this off the bottom, didn't I? This little UC520 box down here is acting as a layer 3 switch. Now notice that VLAN 64 shows an admin status of up and line protocol of down. That's because VLAN 64 doesn't actually exist, first of all, and second off, there's no ports that are active in VLAN 64. In order for that to go active, we have to have a port that is active in VLAN 64. So I'm going to delete it. No interface VLAN 64. It's gone. Doesn't exist anymore. So that's the same concept. I mean, it's exactly the same concept of what we're doing here. We're creating these layer 3 VLAN interfaces for our layer 3 switch. All right, last thing I'm going to talk about is adding virtualization to the mix. Virtualization is the idea of running multiple devices within one. It's, if you haven't heard of virtualization, you've probably been in a cave for the last few years because it's overtaking the world by storm. We used to have to buy servers for everything. Like I would have a physical server that is my email server, and a physical server as my domain controller, and a physical, you get the idea. Every server is its own server. Well, you would check the status of those servers, those physical servers, and you would see them throughout the day running at like 1% processor utilization. You know, they kind of peak up to a 10%, and you're like, oh, look, it's busy. No, it's not. You know, they're using, 20% of their memory. It's just we have hardware there that's not utilized efficiently. So VMware, they were the first to the bat with this. I'll say the first real name in the industry, and they said, well, let's take one physical box and run multiple servers on it, meaning you can actually have one device, physical server that has multiple servers in place. So I can, if you just look at VMware ESXi, or ESX is the older version of it, and you start researching more about that, you find out that you install essentially no operating system on the server itself, except for VMware's little ESX operating system. It's free, by the way. You can go get ESXi for free, and as long as you run it on a single server and that kind of thing, it's very useful. And you can install VMware. It's a little 200 meg install, and then you start creating your virtual machines on top of that. So there's consumer grade virtualization. For instance, if I go to Windows 7. Here's my little Windows 7 box. You can see I've got my Jeremy directory virtual machines. I've got my Windows 7 clean machine. I was just something I was tinkering with. Double click this and it starts Microsoft Virtual PC. This is a PC running on my PC. This is a form of virtualization. Nowadays, Windows 7 Professional and Ultimate ships with this feature. So you can run backwards compatibility mode to Windows XP, but hey, you don't have to do that. You can run Linux. You can run another Windows 7 within your Windows 7. I use this as my little testing machine to try out all kinds of stuff on. Just cancel out of this, but you can see right here I've got how appropriate, right? There, oh, and there it goes. Right. So you can see that I think it's locking up my computer. Oh, there we go. You can see it's a little. This is great. I can actually see it boot. It's a little Windows machine within my Windows machine, and just about anybody can do this nowadays with Windows Virtual PC or VMware Workstation or whatever software you want to use to do it. That's consumer grade. Macintosh with Parallels and Fusion and that kind of thing runs Windows on the Macintosh. Enterprise grade is now where we have our giant physical servers, which now run multiple devices. So let me I don't want to dive too deep into virtualization because we can get deep, and I don't want to steal the thunder from the VMware instructor here at CVT Nuggets, who does awesome at teaching that. I want to talk about how this affects us Cisco folk. What's the scoop? Well, these virtualization servers have the ability to tag packets, meaning that an administrator can actually put their servers, multiple virtual servers, running within a server, within a physical server, on different VLANs. Maybe these two are on VLAN 64, they're voice servers. These two are on VLAN 68, those are maybe our data servers or something like that. They're all running on that one physical box. So how it affects us, as we are integrating with ESX and Microsoft's knockoff, which is Hyper-V. I say knockoff in the nicest way I can. Hyper-V. To where they're going to be plugging into our switch, we're going to need to feed them a trunk port. Meaning we're going to need to configure a trunk to a physical server and then say, okay, I'm going to allow VLAN 64 and 68 to cross that trunk. Because within the server, this server actually has what's called a vSwitch in the VM world, where it has a virtual switch where it has kind of these imaginary switch ports that these guys plug into inside of the servers. They call it virtual because it doesn't really exist inside of that server that these things connect to, and they can be assigned to different VLANs, and then it's essentially seen as a switch-to-switch connection coming out of that servers. Now, Cisco sells servers too. They made a lot of vendors happy when they made this announcement. They have the unified, the UCS servers is what they sell, where they have a really huge partnership with VMware, quasi-huge with Hyper-V and Microsoft, to where they sell their own server platform, Cisco UCS servers that are manufactured to be, I can't even get into the layer of complexity. They virtualize essentially virtualization. They're virtualizing virtual resources so that you can virtually assign them to virtually anything. It's crazy. There's a guy I sat down with from the state of Arizona government where they've got five physical server, and they are hosting 110 virtual servers off of 5 physical boxes. I'm like, you guys are insane. And then they showed me the hardware specs of these servers, and I was like, that's insane. So it's crazy the amount of stuff that people are able to do nowadays with virtualization. But I want to mention it because I don't want you to be broadsided when somebody comes and installs a VMware server, or talking our branch offices. These Windows admins say, hey, we're going to run Hyper-V on our servers. We need VLANs to come to our server, and you go, what? What they're doing is they're putting VLANs within their server to virtualize those separate boxes. See, at least now I'm assuming correct about myself. I knew I wouldn't even be able to touch Spanning Tree just talking about VLANs. There's so much good stuff. So we did a review, VLANs at the core, kind of a play on words there, both in our core switch and understanding VLANs, what they are. We saw how they applied to our designs. We looked at trunk provisioning, adding the right VLANs, created a task list for ourselves when we get to the configuration side of things. We even added in layer 3 switching because that's going to be a big part of what we do. And then finally, we looked at virtualization. I hope this has been informative for you, and I'd like to thank you for viewing.